Okay, a little additional practice. This is take two. This is dedicated to Omar, who doesn't like so many quizzes during the day. You know, he thinks that we're not learning properly. So I have him sitting right up front to make sure that he is completely, excuse me, completely and fully engaged. Completely and fully engaged. Now, you may want to write down in your books or have ready before you even look at this video, and that is the three major equations. VF equals V naught plus AT, D equals V naught T plus 1/2 GT squared, or GA squared, or AT squared. Instead of G, put A. And then VF squared equals V naught squared plus 2AD. All right, so let's begin right away. And every problem on this lecture is going to involve one of those three equations. Every problem you do in this chapter is going to involve one of those three equations. You may have a modified version of the equation, but necessarily you have the equation nevertheless. A supersonic jet flying at 145 meters per second experiences uniform acceleration at a rate of 23.1 meters per second squared for 20 seconds. What is the final velocity? There's the equation. VF equals VI plus AT. You can say VI or V naught. Same exact thing. Now, we're going to plug in the values. Notice that the acceleration due to gravity is not 10. That's for vertical free fall, but it is plus, and it's 23.1 meters per second squared. And then the answer, you do the math, and the answer is 607 meters per second. Pretty fast, actually. A woman driving at a speed of 23 meters per second sees a deer on the road ahead and applies the brakes when she is 210 meters from the deer. If the deer does not move and the car stops right before it hits the deer, what is the acceleration provided by the car brakes? What is the acceleration? Amir, you are talking while I am lecturing. I want you to know that. Okay? No, okay. So it's going to be VF squared equals V naught squared plus 2A, and then the change in distance. Rearranging the equation for A, notice that A is A and not G. Remember, G is strictly for what kind of movement? Vertical, up and down, okay? Plug into the equation and you get what? You get what? You get 1.3 meters per second squared. Now, that could be a negative. See, negative and positive for these kinds of problems, we'll go into it a little bit later. I'll stop the tape and go into it. An inline skater first accelerates from 0 to 5 meters per second in 4.5 seconds, then continues at a constant rate for another 4.5 seconds. What is the total distance traveled by the inline skater? Okay. The total distance traveled by the inline skater will be, this will be in two parts. They're looking for distance in both parts. Distance during the acceleration period, and then distance at the constant speed portion of the experiment. The accelerating distance is going to be the average velocity divided by 2 times time. Remember that velocity is final and initial velocity divided by 2. So that comes out to 11.25 meters. Okay, now at constant speed, we get they're going for another 4.5 seconds at 5 meters per second, and that's just simply going to be the final velocity, or the instantaneous velocity at the point in which the acceleration stops times 4.5 seconds. So it's going to be 5 times 4.5 is 22.5 meters. Then you do the calculation, and now you're going to add the two distances. AJ, you with me? Excellent. You add the two distances and you get 33.75 meters. That's the total distance traveled. Now, you can do these in two parts, the accelerated and the constant, or you could graph it and do the area under the curve. A plane travels a distance of 500 meters while being accelerated uniformly from rest at a rate of 5 meters per second squared. What final velocity does it attain? So you need something that's going to compare velocity with distance. velocity with distance. And that's the equation. Vf squared equals V naught squared plus 2a and then delta d. Now we know that what? That d naught is 0. It's going to start from 0, so V naught is 0. And then so Vf final squared equals 2a df. df is the final distance, or how far it went. And therefore, taking the square roots of both sides, we get Vf equals root 2ad, and then plug into the equation. Notice that the acceleration is plus 5, so it's going to be essentially 5,000, square root of 5,000, which is 71, a little bit less than 71, but rounded to 71 meters per second. Excellent. Now, let's do one more problem, and then we'll do something else. An airplane starts from rest and accelerates at a constant 3 meters per second squared for 30 seconds before leaving the ground. How far did it move? Now we're looking at distance and time. When you think of distance and time, what equation do you think of? Anybody? That's it. df equals v naught t plus 1/2 at squared. And then plugging into the equation, you get 1/2 times 3 times 14 squared, and the answer to that is 1,350. Let's take a break for a moment. You'll never know I was gone. Have a good day. Make sure you enjoy the weekend if I don't see you, and goodbye. I'm back. I want to take a moment out from this lecture and straighten up some possible confusion. And that is the vertical linear motion sign convention. Now, when horizontal motion takes place and something accelerates, we naturally think it as being a positive acceleration. If something's decelerating, we naturally say negative acceleration. But in the normal sign convention on the left, on the slide here, the down is negative and up is positive for G, and as a result, up is negative and down is positive for V. Now, what I prefer is up is negative for G and down is positive for G. Therefore, up would be positive for V and down would be negative for V. The best method, the least confusing method, I think, is what I said in the Darcy method. That's what I'm calling it. It's certainly not called that, but down, it's something's accelerating, it's increasing its velocity. So down would be positive G, up would be negative G. And instead of saying plus or minus velocity, you simply say it's going down at a certain velocity or it's going up at a certain velocity, and that would straighten up everything. So just give a little bit of detail. You know, you can do the problem and then assign later some detail describing the motion a little bit more clearly. Okay, how fast was the plane going when it took off? So what you need to look at is something with a final velocity, and you want to stop this and go back to the original problem and see that, well, you're going to have the time, and you know that the initial velocity is 0. The time, again, is 30 seconds. The acceleration is plus. See how that's a horizontal, and you automatically assume that it's plus? And then 3 times 30 is 90 meters per second, which would be the final instantaneous velocity. The average velocity, of course, would be 45 meters per second. A construction worker accidentally drops a brick from a high scaffold. What is the velocity of the brick after 4 seconds? What is the velocity of the brick after 4 seconds? Well, if it's dropping from rest, it would be 40 meters per second, 4 times 10. Or you can simply say, well, downward is positive, positive G or positive A, and you would multiply the VI would be 0, so multiply 10 times 4, and it's going to be 40. You can intuitively come up with this answer just by knowing what G means. So the answer would be plus 40 meters per second, or you could say down, you'd be going down 40 meters per second. Clear? Okay. How far does the brick fall during this time? So time and distance. So the equation would be D equals V naught T plus 1/2 GT squared, and you simply plug in. V naught, or VI in this case, would be 0, and then you're left with 1/2 GT squared, where G is going down, so G would be positive 10. So 10 times 4 squared times 1/2 is 80 meters. So it would be going 80 meters. You could say plus 80 meters. You could say it's going forward 80 meters as opposed to backwards 80 meters, or down, whatever the case would be. You might want to use some description if you're actually doing a calculation. Describing the motion would be very important, especially if you're taking a standardized IB or AP test, etc. Suppose for the previous problem you chose your coordinate system so that the opposite direction is negative. What is the brick's velocity after 4 seconds? Well, it's going to be the same velocity. Again, you simply have to say it's going down. If you want to say the opposite acceleration, say it's negative, all right, fine, that's fair enough. Well, you're still going to get the same scalar quantity. They're using 9.8 here. It's the same. Some books use 9, some use 9.8, some use 10, some use 9.8. And you have negative 40 meters per second. But, and that's rounded, but you could save all these problems and just say it's still going down 40 meters per second. A construction worker accidentally drops a brick from a high scaffold. How far does the brick fall during this time? Again, you're using opposite, but if you, again, describe the motion, describe your answer, you could be wrong. What you're actually calculating using the math, I guess, is the scalar quantity, and then you're assigning it direction to make it a velocity. Acceleration and velocity are both vector quantities. So here you would get negative 80 meters, but you describe, instead of going up, it's down, still down, so the brick is falling 80 meters. The brick is still falls 80 meters, no matter what sign you use. So the sign convention is a very important thing to understand. A student drops a ball from a window 3.5 meters above the sidewalk. How fast is it moving when it hits the sidewalk? So velocity and distance is what we're looking for. Comparing velocity and distance, V of D, and you simply plug in, understanding that V naught squared will cancel out because V naught is 0. A equals G because it's vertical. It's going down, so we're going to say it's plus 10 meters per second squared or plus 9.8 meters per second squared, and take the square root of both sides. You get VF equals root 2AD as your answer to that. Now, just keep in mind, describing the motion is critical. Down, up, sideways, left, right, north, south, east, west. Describe the motion. You don't want any question as to whether or not you're right or wrong. Here, this is 8.3 meters per second. In other words, always use your audience to be someone who might be a year younger than you. A tennis ball is thrown straight up with an initial speed of 22.5 meters per second. It is caught at the same distance above the ground. How high does the ball rise? How high does the ball rise? So again, it's going to be VF of D, and there you have it. Now G, it's going to be going up, so G is negative, and what you'll find is that V naught, no, sorry, VF is negative. V naught is 22.5 meters per second. And so plug in and simply crank it out. Again, you can't be wrong with signs if you simply, very briefly, very concisely describe the motion. Okay, enough said. Okay, so this one is going to be 22.5 squared divided by 2 times 10, or 2 times 9.8. And the answer is direction as in plus or minus must be assigned by inspection and then stated as a description as in the ball rises 25.8. Next, how long does the ball remain in the air? Hint, the time it takes the ball to rise equals the time it takes to fall. You add the two and you'll get the time it remains in the air. Calculate the time to rise using VF equals V naught plus AT, with A is negative G and VF is 0. So there's your equation. Understand that VF is going to drop out because VF is 0. V final is 0. So then you have 0 equals V naught plus negative GT. You want to subtract V naught from both sides, and that gives you negative V naught equals negative GT. Divide through, T equals negative V naught divided by negative G. The negative signs cancel, and you're left with T equals V naught divided by G. V naught divided by G. Now what we'll do is we will plug that in to the equation. We'll plug in the values, V naught and G, and when you do the calculations, you see very clearly and cleanly that it's 2.3 seconds. Now, be aware it's 2.3 seconds. The time to fall equals the time to rise, so the time to remain in the air, don't forget this, is 2 times 2.3, or 4.6 seconds. So the ball remains in the air 4.6 seconds. Next, your sister drops your house keys down to you from the 2nd floor window. If you catch them 4.3 meters from where your sister dropped them, what is the velocity of the keys when you catch them? Okay, let's move a little bit more quickly. We see that the equation is going to be VF of D. G, we plug in G. We understand that VI, V naught is going to cancel out. We take the square root of both sides, and we're left with VF equals root 2AD. Then we plug in the various articles. Notice that 9.8 is positive, so root 2 times positive 9.8 times 4.3 is positive 9.8 meters per second. A student trying out for a football team kicks the football straight up in the air. The ball hits him on the head on the way back down. It took 3 seconds from the time the student punted the ball until he gets hit by the ball. What was the football's initial velocity? Well, let's try to reason this out. Round trip is 3, so up is 1.5, down is 1.5. 1.5 times 10 is going to be approximately 15 meters per second. Okay? It'll be a little bit less than that if you use actually 9.8 meters per second squared. So you say it's going, the velocity is 15 meters per second up. Yeah, that's what you would say. Just to be clear about putting a little description in there. When the student in the previous problem kicked the football, approximately how high did the football travel? So again, we're going to use VF. Now that we have VF, uh, or VO, whatever the case may be. We'll plug in negative G. And we have, hi, we have a visitor here. I'm taping a thing. We have a, nice to meet you. God bless New Zealand and Australia in that order, of course. Have a good one. And we see, we just, we solve for D, and now we plug in, and we get the negatives cancel, and we are left with the height of 11 meters. We're left with a height of 11 meters. Okay, so very basic. This is starting to become all the same. A car moves at 12 meters per second and coasts up a hill with uniform acceleration of negative 1.6 meters per second. It's going uphill, so it's going to decelerate. What is its displacement of 6 seconds? So we're going to look at displacement, or D, or distance, same thing. In terms of time, V naught is going to be 12 times 6 plus 1/2 AT squared, and you're going to get a distance of 43 meters given that data. A car moves 12 meters per second and coasts up a hill with a uniform acceleration of negative 1.6 meters per second squared. What is its displacement after 9 seconds? D equals V naught T plus 1/2 AT squared. Right. So the initial velocity is 12 times 9 seconds plus 1/2 negative 1.6 times 9 squared. And that is going to be 43 meters. Compare that with the problem when it was 6 seconds. Right. Next, race car problem. A race car can be slowed with a constant acceleration of negative 11 meters per second squared. If the car is going 55 meters per second, how many meters will it travel before it stops? Now, notice that the deceleration is 11 meters per second squared. That's almost 1 G. That would be your weight. 2 G's would be twice your weight. We'll talk about that a little bit more when we do Newton's laws. Okay. Vf squared equals V naught squared plus 2AD. Vf is 0. I'm repeating the problem again. Vf squared equals V naught squared plus 2AD. Solve through. Vf squared term cancels. Notice that A is negative acceleration, and solve through for D, and you get 137.5. Now, what is 4 times 137.5? What is 4 times 137.5? Write that down. We'll look at that later. Okay, now, how many meters will it take to stop a car going twice as fast? Now we're going to go twice as fast. Okay, well, so it's the same exact equation. We're going to solve for the distance. Okay, how many meters will it take to stop a car going twice as fast? Same idea, same exact problem, same exact numbers, but instead of 55 meters per second, we're going to put it 110 meters per second. Notice that it is a squared function and the v final drops out. Look, you see it's 110 squared instead of 55 squared. It's still 2 times 11. So the answer is going to be 550. Now, what was 4 times 137.5? It was 550. 550 is 4 times longer than when going half the speed. That's the problem. That's what we were doing. You double the velocity, you double the stopping speed. Next time you want to tailgate somebody on the road, think twice. Think twice. A speeding car is traveling at a constant speed of 30 meters per second when it passes a stopped police car. The police car accelerates at 7 meters per second squared. How fast will it be going when it catches up with the speeding car? We're going to do simultaneous equations, and we're going to treat the data. And the big differences here is when the policeman catches up with the car, they will have gone the same distance for when the policeman starts to accelerate. So the speeder is S, the police is P. So the speeder will go at a constant velocity, ds equals v, vt. The policeman will go, they'll accelerate, v naught is 0. So that term v naught t cancels out, but you still have 1/2 apt squared. V naught again is 0, so that term cancels out. So you have the two major equations. You have ds equals vst and dp equals 1/2 apt squared. Now, simultaneous equations. We know that ds equals dp, that the distances are equal. So I can say that the distance the speeder goes versus the distance the policeman goes, they're equal. So VST equals 1/2 APT squared. Set it equal to 0. Factor out a t. The t factors out. The t will be 0. And that is worthless. It means nothing. That the time would be 0. That makes no sense. So I will be quiet for a minute and let you see how that works out. And here you are going to solve for t. So you have 2vs over ap equals t. And let's summarize. I'm putting the question at the bottom so that you can refer back to it. What is it that you're exactly doing in case we forgot? So t equals 2vs over ap. Plug in your values now. Plug in your values. And you get, let's see, can you do this yourself? How are you doing? Can you put it on pause and try to catch up with the derivation of this? Plug in the values from the problem, and what do you get? 8.6, did you get it? Okay, so the final velocity will be simply AT, and it's going to be 60.6 meters per second. 60.6 meters per second. Okay. How'd you do? How'd you do? Stop it. Start it, try to do the problem again before we go on to the next problem. Do it over. Okay? I'll take a break. Be right back. So this was such an important problem. Before we go on to the next problem, I want to review what we did. And that is, we wanted to know how fast will it be going, the police car, when it catches up with the speeding car. Remember, you went back in the problem and plugged in for VF equals V naught plus AT, and you came up with 60.6 meters per second. which is really, 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 really fast. Okay? It's a very dangerous situation to speed. Very dangerous. When we talk about momentum, it will become clear just what the stakes are when you do speed if you ever got into an accident. All right? Take another break, go over the problem again before we go on to the next problem. Now that was a very important problem. That was simultaneous equations and substitution. Make sure you can do that problem. There were two solutions. One was discarded. This is going to be equally difficult. Matter of fact, if you can do this problem, you've arrived. The driver of a car going 90 kilometers per hour suddenly sees the lights of a barrier 40 meters ahead. It takes the driver 0.75 seconds to apply the brakes, and the average acceleration during the braking is negative 10 meters per second squared. You want to convert 90 kilometers per hour to meters per second, so that's 25 meters per second. And then how fast was the delayed reaction, the 0.75 that you didn't put on the brakes, so you waited? You went 18.8 meters. Now, here's the equation. What distance are you going to go with the distance with the deceleration, and you want to go a distance, and you already went a distance because you had a delayed reaction. But now what you want to do is you want to see, well, how far am I going to go during this deceleration process? Now, you're going to go the left term plus the right term plus 18.8 is 50 meters. So wait a second. You're decelerating. You're going 18.8 meters before you even decelerate. And something doesn't make any sense here. Well, the idea is that you're going to go boom. You're going to go boom. So it's going to be 625 over 20 plus 18.8 equals 50 meters. So do the math. The math doesn't lie. So if you have 40 meters to stop, what's going to happen? What's going to happen? You're going to go boom, boom, boom. You're not going to make it. So you're going to get into an accident. Now, so you're going to hit the barrier. Now, this is the question. This is the biggie. You ready? Now, what happens if you ask the following question? What is the maximum speed at which the car could be moving and not hit the barrier 40 meters ahead? Assume that the acceleration doesn't change. Same acceleration, it doesn't change. So now let's go through a calculation where you're not going to hit the barrier. You're going to stop in time. So the total stopping time is going to be 40 meters. You went through a constant value of some value, v times 0.75. Again, we don't know the velocity. So that's going to be one problem to do. So the deceleration process is going to be v squared over 20 meters per second squared, because that's 2 times 10. So 40 meters equals total equals the distance covered by the constant and by the deceleration. So this is the equation you end up with. You end up with 40 equals v 0.75 plus v squared over 20. So you can multiply through by 20, multiply both sides through, isolate your terms, do whatever it takes, and I'll let this play out a little bit and see if you can make sense. Now you can see what's shaping up here, and that is a quadratic equation. So it'll be v squared plus 15v minus 800 equals 0, and then essentially plug into a quadratic equation. So there's the equation, and it looks just like a quadratic equation, and instead of factoring it and doing all those sorts of things, you can just right away apply the quadratic equation. Now, this is the problem. Do you remember one of the last things you did in Algebra 1? Do you remember what the quadratic equation is? Negative b plus or minus root b squared minus 4ac divided by 2a. Plug in. Negative 15 plus or minus root 15 squared plus 4 times 1 times 800 divided by 2 equals that. Remember, it's negative 15 plus or minus the root and then divided by 2. So the problem can't be negative, so it can't be negative 15 minus 58.5. It's got to be negative 15 plus 58.5 divided by 2, which is 22 meters per second. So that's the fastest you can go. Now, this is the deal. This is the deal. I will have, hopefully you're going to see this video. And if you come after school, I'll pick a day, and I will give a problem, different numbers, but a problem similar to this. And if you can do it, if you can do the problem using the quadratic equation, I will give you credits. Okay? End of lecture 6. Make sure you look at all the lectures before the test. Okay? Check the Edmodo, check the grade sheet to know when these assignments are and what it is you have to be prepared for. Okay? Have a great day and goodbye.